This is a recitation for the previous lecture on coordinate geometry. It will have 4 questions, and I will just illustrate the solutions to these questions. Let this point 1 minus 2 be a point in the plane r squared, and we want to plot the following points. The point Q such that PQ is perpendicular to the x-axis and is bisected by it. The point R such that PR is perpendicular to the y-axis and is bisected by it, and we are requested to give the coordinates of R. The point S such that PS is bisected by the origin and give the coordinates, and the point T such that PT is perpendicular to and bisected by the 45-degree line through the origin that bisects the first and third quadrants, and give the coordinates of T. Now, there are a few subtle things that need to be outlined. A couple of them are very straightforward though. So with the point P, that's 1 minus 2, we can see it over here. And it says that we want PQ to be perpendicular to the x-axis and bisected by it. So perpendicular obviously means that it must make an angle of 90 degrees, and bisected means that there must be equal lengths on both sides. So in other words, it must be divided by 2. So that tells you how far across in this direction to go. You must go no further than the length of this line. So that makes you end up at the point 1, 2. So we can see that what really takes place is the sign on the y component is what changes. It goes from negative to positive, and that's the solution for part A. So for part B, we're starting at P again, but we're going horizontally, and we want that the y-axis should bisect that line. So we end up at the point R, minus 1, minus 2. So the change is that the x-coordinate turns negative in this case. Part C asks for the point S such that PS is bisected by the origin. That one is a little different. You start at the point P and you want to draw a line such that the origin is the middle of that line. So what we do is we start from P, connect to the origin, and then keep going, but for the same distance as from P to the origin, and we end up at the point S, which is minus 1, 2. And what we realize here is that when you have this sort of setup with a point being reflected in the origin, the signs on both of these coordinates change, because it goes from 1, minus 2 to minus 1, 2. And then D, it says the point T such that PT is perpendicular to and bisected by the 45-degree line through the origin that bisects the first and third quadrants. So the first thing to observe is the way the quadrants are labeled. We always go anti-clockwise. So the first quadrant is here, second, third, and fourth. This line L is a 45-degree line. It's 45 degrees. And as they requested, it bisects the first and third quadrants. And from this point P, we want it to be reflected in this line and extend no further across the line than from P to the line. So we end up at the point minus 2, 1. And this point, you can observe, is what really happens here. We switch the x and y values when we're reflecting in this line, the 45-degree line that bisects the first and third quadrants. And I would like to point out that this line has a special equation that you probably already know. This is the line y is equal to x, because for every point, let's say you take 2, go up, it maps to 2. You take 4, go up, it maps to 4, and so on. Now for question 2, if the point P has coordinates x and y, then the coordinates of Q are x and minus y. What are the coordinates of R, x, and t? So in this case, our x and y is actually a and b. So let's just put in what they gave us for Q. That's a and minus b. And this makes sense because we're still at the same place on the x-axis. so the x-coordinate must stay the same, but on the y-axis we go from b all the way down to minus b. So we were here at b, we're down there at minus b. So those coordinates for q make sense. Now what about r? What does r look like? Observe that r is at the same level as p, so that means the y-coordinate for r is supposed to stay the same. But it extends the same distance along the x-axis, but just to the left of the y-axis. In other words, we still go this same distance, only on this side. So what we need is to have the same x-coordinate, but with a negative sign on it. So the coordinates of r are minus a and b. But what about s? How is s changing? What does that look like? Well, it's in the region where we have negative x coordinates and negative y coordinates, and it's a reflection. It's a reflection in the line y is equal to minus x. So it's not too hard to see that it should be minus a minus b, because it travels, in order to end up here, if we start from the y-axis, we have to travel a units in this direction, it's minus a, and we have to travel b units vertically, that's minus b. So the coordinates for s are minus a minus b. Question 3 is a little different, but it just requires us to understand what tangent means. It says a circle is in quadrant 2 and is tangent to both axes, and it touches the y-axis at 0, 3. At what point does it meet the x-axis? And they want us to find the coordinates of the center of the circle. Remember that the quadrants are 1, 2, 3, and 4. So we are in the second quadrant as they want. The information given is that the circle touches the y-axis at 0, 3. That's here. So it's tangent to the y-axis. That means it makes a 90-degree angle with the y-axis. The radius makes a 90-degree angle with the y-axis. If it's also tangent to the x-axis, it means that the radius should make a 90-degree angle with the x-axis as well. Now, if you think about how you can go from this line to this line, we actually have a rotation in 90 degrees. And that would just bring us to minus 3, 0. So just by understanding that situation, we can deduce what the coordinates on the x-axis would be, minus 3, 0. And because of those two coordinates, minus 3, 0 and 0, 3, we know that the center of the circle must have coordinates minus 3, 3. Question 4. The line through the points 1, 1 and 2, 0 cuts the x-axis at some point, 0b. We are to find b by using similar triangles. And remember, similar triangles are triangles where the angles are preserved. So the original triangle is here, this one, because we have the points 1, 1 and 2, 0. So we want to know where it cuts the y-axis. So we continue the line up to here. Now, why is it 0, 2? Well, if you think about how this whole triangle is being constructed, observe that on the x-axis we have a doubling of the lengths, and on the y-axis there's another doubling of the lengths. So it's not too hard to see that the y-axis coordinates should be 0, 2.